In this video, you'll learn about scatter plots and linear regression.
Pickup, even when her bladder makes a little drop off. Because Candace has poise. Poise under pressure and poise.
A scatter plot is just a graph of ordered pairs, plotted points, that show some relationship between two sets of data. There are 4 scatter plots here. The first one in pink is the square footage versus the price for homes, where the square footage is the independent variable and the price is the dependent variable. We always put the dependent variable on the y-axis. The next one, final exam score versus age. The third one, age versus price in dollars. And the last one does not have any axes marked. But they are all scatter plots. Which scatter plot would a line of the form y equals mx plus b fit better? Well, in this particular case, it's probably the third one. In this third one, we can see that there is a trend going down. For the others, this one kind of grows quicker, so we might think of an exponential function. And the other two don't really have a kind of relationship. So we might think that the age versus the price in dollars is the graph that would give us a y equals mx plus b form of the equation. When a scatter plot shows a linear relation, you can use technology and find the line of best fit. That's called the least squares regression line, and it's modeled by y equals mx plus b, but we use y hat equals ax plus b. Y hat means that the line is a regression model and is used to make predictions. Associated with each least squares regression line is a correlation coefficient. And the correlation coefficient tells us how strong our relationship is. So if we look at this chart down here, a perfect positive correlation where everything lines up in a line and has a positive slope, the R value is going to be 1. On the other end, if R equals -1, it's a perfect negative correlation. Between that, right in the middle, is a scatter plot that really doesn't show any correlation. That R value is going to be 0. And then we can see that depending on how strong our relationship, how close the ordered pairs are to a perfect line. So R value close to 1 or -1 is a strong correlation, and an R value close to 0 is a low correlation, or not a very strong, weak, we would say a weak correlation. So we're going to use the data in the graph below to find a linear regression model that fits the tuition and fees data. So our tuition and fees data is given by the black graph. So we're talking about this graph here. And we need to have some way to correlate, in other words, have an x value and a y value. So what we're going to say here is that 1980, so let's let 1980 to 81 be x equals 0. So in 0, we would have 0.2, and let's up here say in thousands. I'm going to fill in the table with the other values. So we notice that each of the years goes up by 5. So our x values increase by 5 every time. And I have written down the correlated y values. Let's find a model first and then use the model to predict what the cost of tuition and fees would be in 2025, which would be the next value here, 2025, which should be 45. So we want to use the model to find the corresponding y value. So how do we do this? Well, we can just use 2 ordered pairs and probably find a fairly good model. Let's do that first. I'm going to go ahead and use this ordered pair, 10.7, and the last ordered pair, 40, 3.3. So if I find the equation of that line, it's just going to be the line that connects those 2 points. So just sketching this, it might look like this. And that looks like a pretty good guesstimate of what that line might look like, but let's go ahead and find it. So we're going to find our slope, and that's y2 minus y1 over x2 minus x1. That gives us 2.6 divided by 30, which is approximately 0.087. So that's the slope of the line. And if you like, which is always a good idea, we should think about the units here. This was the difference in thousands of dollars per difference in year, so 0.087 thousandths per year. Okay, having said that, that's our slope. We have to pick a point that is on the line. I'm going to go ahead and use the 0.7 and the 10. It really doesn't matter which of these 2 ordered points I use. So if I use this as my x1, y1, and I plug it into my y minus y1, equals my slope times my x minus x1, I will get y minus 0.7, 0.087 times x minus 10. So distributing my 0.087, I get 0.087x minus 0.87. Let's now collect like terms, and we'll add 0.7 to each side, and we get y equals 0.087x plus, or actually minus 0.17. All right, and because this is a regression line, or actually this is we've just used 2, so we're trying to find a regression line. We're going to call this y hat, because we want to use this to approximate what's going on. And we want to know if x is 45, so we'll put a 45 in here for x. What do we expect the fees to be, tuition and fees to be? And it appears to be 3.745. So we would predict the tuition and fees in 2025 to be 3.745 thousand. Okay, so think about this for a second. We only used 2 ordered pairs, but we actually have a whole bunch of ordered pairs. We have all of this. And if I only use 2, it's only accurate, using those 2 ordered pairs. But if I use all of the ordered pairs, I can use my calculator to help me find what that least squares regression line is. So I am going to copy onto the next slide these ordered pairs and then show you how to do that using your calculator. Okay, so I've copied down the data here, and our question is, in the year 2025, which we've called year 45, what are the tuition and fees in thousands? So what we're going to do is we're using our graphing calculator, a TI, and we want to input values into list 1, which is called L1, and list 2, which is called L2. And to do that, you're going to click the key that says Stat, and then Edit, and you can actually fill in L1 and L2 with these values. Once you do that, you can hit second function, quit. So we'll put those values in, then we're going to do second quit. And I should mention, if you already have data in your two lists, you can use the cursor to highlight L1 or L2, hit clear, and then hit enter. So we have our data in our two lists. The next thing we're going to do is type, we're going to hit the stat key again, only now we're going to go over to calculate, and we're going to go down to number 4, which is lin reg ax plus b. So it's going to find a linear regression in the form ax plus b. And by default, it's going to use list 1 and list 2, and we've already got that data in there, so we can just hit enter. Now, what shows up for me is y equals ax plus b, a equals 0.0886 repeating, b equals negative 0.028 repeating, r squared equals 0.9617 continuing, and r is 0.9806 and continuing. So remember, r is our correlation coefficient, and we actually can interpret this to be y hat equals 0.089x minus 0.029. And I'm just rounding up because of the decimals. Okay, so let's take a look. If I plug in my 45, what do I get for my value? I get 3.976. So our prediction for year 2025 would be 3.976 thousand. Now, how is this different from what we did on the previous slide? Well, on the previous slide, remember we had y equals 0.087x plus 0.17. This was using only 2 points. And this one here, the calculator helped us, is using all of the points. So this is really the least squares regression line. This one here is really just an approximation of the least squares regression line. We only use 2 ordered pairs. But if we don't have a calculator, then we could do that. That concludes this video on linear regression and scatter plots.